Okay, so let's get into it. My name is Joy Fosnot, and I am a Principal Solutions Architect with our AWS Aerospace and Satellite team. And I have the great privilege of getting to work with aerospace and space customers all around the world, which is so much fun. And if you have not visited our aerospace and satellite booth, it's right behind me. So when I'm done, go check out our demos, see some cool technology. So today, though, we're going to be learning about a solution that our AWS prototyping team has built and developed to use AWS Edge Computing to manage software updates on fleets of aircraft. Here's our agenda. First, we're going to spend a little bit of time in a history lesson, right? The evolution of connected aircraft. We're going to talk a little bit about some of the things that have enabled that to be what it is today in 2023. And then we're going to talk about some operational challenges that our customers have shared with us. Next, we're going to go into an architecture that our prototyping team developed along with a demo of that prototype that helps our customers solve that operational pain. And finally, if time, right, like I said, 20 minutes is going to go really fast, but if time, there'll be some Q&A, and if not, we're going to stick around and take your questions outside there. Okay, so let's talk history. So these gentlemen on the left, that's the Wright brothers, if you're not familiar. So they originally developed some of the technology and the inventions for not human-powered, but human-carrying powered flight in their bicycle shop in Dayton, Ohio. So that's my hometown. That's where I live. Where they did a lot of their testing is literally like 3 miles from my house on the Huffman Prairie Flying Field. So I think this is super interesting. But also, I like these two pictures because it's a big contrast, right? So this is what it looked like to fly in 1903. We're going to have the 120th year anniversary of that first flight in North Carolina in December coming up. So it'll be 120 years since they took that first flight. And really, that's only a lifetime and a half. So in that lifetime and a half, we've gone from open cockpits, no connection, to this experience on the right. And that's how we all want to experience flight right now. We want to be able to walk on. We want our devices to connect. We want the seat backs to be up to date. We want to see movies. We want to have the games work for our kids on those long flights, right? So this is kind of where we are in a very short time. So some other reasons that connected aircraft and that connected experience is important. It's not just for passenger experience, but also for operational efficiency, the ability to create analytics from data that's collected. There's many, many sensors, of course, on board aircraft. And so all of these things are enabled in a connected aircraft environment. So we can't be where we are with a connected aircraft experience without advancements all along the way in satellite communications. So this timeline just shows some of those advancements in satellite communications that have taken place since basically the 70s. And so our experience has come along with this journey in SATCOM technology. And all of these advancements have led to further and further capabilities for us inside that aircraft. So we've had the ability to have in-flight Wi-Fi. Only recently has that come about. I don't know who all remembers the old telephones in the backs of the seat backs. You'd put your credit card in, right? You'd be able to make a phone call from your seat. So all of these capabilities have come into being basically because of SATCOM advancements and antenna advancements. And with the capabilities coming in low Earth orbit connectivity, this is just going to be even more advanced in the future for us, with the ability to do even more Internet of Things, constant connectivity, analysis of that data in flight, in near real time. However, having a connected aircraft means software. And software means Updates, right? So we have to be able to update that software. Not in flight, sorry. We have to be able to update that software. And we've heard many kind of pain points around this, honestly, from our customers. One of our customers from Safran Passenger Innovations, he's a senior director of software development, and he told us this during a podcast this year. He said that being able to push these updates to the aircraft shouldn't require an engineer, right? It definitely impacts the bottom line of these customers. And what he said exactly was there's no reason why meal menu updates should require an engineer to visit that aircraft. But that is exactly what has to happen right now. So when you sit on your airplane and you watch a recent movie that's just come out, you need to realize how that happens. How that happens is a maintenance technician has to visit a service control unit computer on board that aircraft with an SD drive. They have to plug that SD drive into that service control unit and get that update to happen. And this causes a lot of logistical pain for our customers. They have to burn these SDs, they have to FedEx or UPS them out, and they have to shuffle them, they have to maintain, they have to deploy and track all these SD cards. And that's just something that AWS and our prototyping team wanted to see if they could develop a prototype solution to fix that operational pain. And this is the architecture that prototyping team developed. So the solution that they developed to make strides towards solving this operational pain is an AWS IoT, Internet of Things system, using IoT Core and AWS IoT Greengrass capabilities. Also, the team developed a very easy to use dashboard for ground side use for those technicians to use, as well as some custom Greengrass components that I'm going to spend, even though we'll talk about that in a second as we move through the architecture, I want to talk about those components and how powerful those are. So Greengrass provides the ability to create custom software and package it up and deploy it onto an edge device. And a couple of key components that prototyping team developed are these two that we show here on the left. On the right, the job manager and the file downloader. We'll talk about those in more detail, but that file downloader is key to how our customers are reacting to when we show them this prototype, because what it allows them to do is not have to maintain and manage the fact that an aircraft is going out of connectivity. They'll push an update to an aircraft, perhaps a new bundle of movies, and as that aircraft maintains or loses connectivity, the file download just picks up, just pause and resume, seamlessly without any human interaction. But if we move through this architecture from the left to the right, it starts on the dashboard down here on the bottom. So the maintenance technician interacts with that dashboard. They create bundles of software updates or media updates as Greengrass components. And this idea of a component and a deployment is key to how Greengrass works. And so as they bundle items up and create deployments, that affects the state of the desired state, or expected state rather, of that Greengrass device. And then the inherent ability of Greengrass on board that service control unit computer that's a part of that aircraft realizes that it needs to do new updates, and it all works seamlessly and just based on MQTT protocol over the air for over-the-air updates. The dashboarding system also allows the maintenance technicians to basically put these items, these media updates, movies, new games, maybe scripts that they have to run into an S3 bucket. And that's the basic storage system of the content management system that is a part of the demo that I'll show you in a second. All right, so let's move on to the demo then. Okay, as a part of this demo, you're going to see two tabs here. The first tab, as I mentioned, is this custom dashboard that our prototyping team developed. And the dashboard was really important as they started talking to customers. Customers don't really want their technicians to be interacting with the AWS console. They wanted a smooth, streamlined, easy user interface for those technicians to understand, in a way that's very human consumable, and it was able to, create a smooth experience for them that easily drops the files into the bucket without them having to interact directly with it. So the content manager part of this dashboard is where the technicians do interact again with under the covers an S3 bucket. So they can add new files, for instance. They can create any different type of file that they need to put into the bucket. They could create bundles of movies, bundles of things that they need to do. And again, this idea is key for Greengrass, right? You've got components and you've got deployments. So components are the things that get pushed. Deployment is the package around those things that gets pushed. And so you can configure a deployment to be a variety of different things that's going to go to a service control unit computer on board an aircraft or an entire fleet of aircraft. And so other items that you'll see on this dashboard for the component deployments, you've also got whether that deployment, for instance, is going to an entire fleet or just one aircraft. You'll see status of the deployments. You'll see the date that deployment was created. And again, you'll get this kind of high-level dashboard picture of the deployments that the technicians are packaging together and managing on behalf of the aircraft. You can do upgrades as well. And all of this is just basically wrapping just key IoT Greengrass capabilities that are available across many, many different types of devices and flavors of devices. So I also wanted to show a key aspect of IoT Greengrass is this concept of breaking items into what's called things and thing groups in Greengrass. So a thing is basically one item, right? I mean, simple enough terminology, but a thing group can be an entire set of things. So this allows the ability to group items for deployment using Greengrass. And so, for instance, in the future, as we have more and more connectivity to those aircraft, we will have the ability to have sensors, right? And so we can have Greengrass capabilities deployed to sensors like seat belts, like tray tables. And I guess that's I'm in trouble because now they're going to know if I unbuckle my seatbelt or if I have my seat back a little bit when I'm not really supposed to. All right, next we're going to switch over to my AWS console. So I'm going to show you a peek under the hood of what's actually going on as the user is interacting with this dashboard. So again, what you see is the Greengrass core devices part of the AWS console. And so the service control unit, which is, again, is an onboard computer on the aircraft for non-critical systems. That service control unit has the AWS IoT Greengrass core engine installed upon it. And so you will see also on this, you can track using this part of the AWS console, you can track deployments, you can track which Greengrass components are a part of that deployment. What Greengrass components have actually been deployed onto that service control unit. And in this case, again, some of these components are custom components. That file downloader from S3 that I mentioned, as well as like the dashboard manager itself and the job manager to know when to pull new files from the S3 bucket. So when you have a deployment, one really powerful thing you can do is you can revise it, but you don't have to revise the entire thing. So a deployment might consist of 6 or 7 different components, but maybe you only need to upgrade the version on one of those components. You can do that with the revised deployment capability. And in Greengrass, one really powerful thing that they do have is that components can be both public and custom. We'll show you that in just a little bit, but this is where I wanted to show the ability to break and create a hierarchy of things into things and thing groups. And so if you think about needing to push software updates to a fleet of aircraft, for instance, you might have different eras of aircraft. And so you might want to push some updates just to this part of your fleet, other updates to that part of your fleet. This is where you do this, in the things and thing groups hierarchy creation. And so you can target a set of deployments and revisions that only go out to a certain part of your fleet, for instance. So back to the Greengrass core devices, the other thing I wanted to show you here was, again, this idea of components is key to Greengrass. You can have custom components, which again are these custom capabilities that our prototyping team developed in this case. You can have public components, which is all of the components that AWS provides for Greengrass devices. And there are also third-party components that are developed in the open source world. And interestingly, the Greengrass team just announced on, I think, November 22nd, a third-party catalog of components that now you can purchase that are managed and maintained by that third-party entity. So that's a new thing that just came out for the Greengrass device catalog. It's a very exciting new deployment idea to check out. All right, and that is it for the demo. All right, so to wrap up then, just a few key takeaways with some QR codes if you're interested in checking these out. So that connected aircraft architecture that I showed is available from our architecture repository. That's the top QR code. The middle QR code just takes you to the Greengrass documentation, and you can learn more about doing over-the-air updates using AWS IoT core capabilities and Greengrass capabilities. And then finally, that last item I put a QR code to there, a super interesting blog that was written about using Amazon Forecast to predict SATCOM analytics. Why that's important to the aircraft industry, as well as many other industries like maritime, struggling for the word there, maritime and the military, is SATCOM usage can really vary a lot depending on the time, depending on weather patterns, et cetera. And so that blog gives a really nice solution for using forecast to predict usage of SATCOM bandwidth. All right, and so with that, I want to say thank you. Please complete your session survey. This is, Amazon.com, not Amazon.zom. Sorry, that is my email address. That's my QR code to my electronic business card. So, connect up with me. Would love to hear more. If you're interested in this use case, interested in the prototype, for instance, that our prototyping team developed, we'd love to hear from you on that.